simply reaction of acid with metal oxides and reaction of base with non-metal oxides. So for this, you require materials, right? To observe the reaction of acid with metal oxide or base with the non-metal oxide, right? Base with non-metal oxide. So two reactions you are studying, observing. Okay. So for this, you require materials. What they are here? Simply, you require a base, right? Metal oxide. That is copper oxide. Copper oxide. The next, you require acid to observe the reaction of acid with metal oxide. Copper oxide and acid are selected. Next here, beakers required, glass rod, right? You need to stir it. You need to stir it because here copper oxide is a solid material. In the previous, we taken directly liquid solutions, so they can dissolve or they can mix together easily. But here, diffusion of this, right, dissolving of copper oxide in an acid, we need to stir it, right? So that's why we are taking glass rod. So why not a metal container spoon? Because metal may react with the acid. That is the reason to avoid that. Okay, so we are using glass rod. The next here, I need a gas, carbon dioxide. Why, sir? Carbon dioxide is acidic in nature. Carbon dioxide is acidic in nature. So next reaction is non-metal oxide. So carbon dioxide is non-metal oxide. Carbon is a non-metal oxide form. Carbon dioxide. So non-metal oxide. For that combination, I need a base. That I am taking lime water here. That I am taking lime water. So carbon dioxide lime water reaction is base non-metal oxide reaction. Copper oxide and acid reaction is acid metal oxide reaction. Okay, so these are the reactions we are carrying out. So here I am not conducting the procedure because here we are able to generalize this reaction as neutralization reaction. Here what the observations you are going to make in this reaction by adding of copper oxide into the acid beaker. So you are taking a beaker, adding HCl into the beaker. After that, taking copper oxide and stirring. So slowly add copper oxide crystals, right? Then stir it constantly. Observe the change in the color. Actually here, copper oxide, blue colored salt. So on adding of HCl and copper oxide, you will get a bluish green colored liquid. Bluish green colored liquid. So that will indicate you here that nature of the substance salt formed new product calcium, sorry, copper chloride, cupric chloride, right? So this is the procedure actually you are following. I'm not conducting that. Then here, what about carbon dioxide and lime water test? Already we completed this reaction in the activity number 4. Passing of carbon dioxide gas, which is formed by the combination of acid and the metal carbonate or metal hydrogen carbonate, liberating carbon dioxide, that we are passing through the delivery tube into another glass tube containing lime water. So we observed in that white precipitate is formed. So that is giving you a salt. What is giving you? Salt, calcium carbonate and water. So commonly what you are observing by the reaction of acid and the base copper oxide producing you a salt that is cupric chloride, aqueous solution and water forms in this reaction. Next, on reaction of calcium hydroxide, lime water, basic in nature, with non-metal oxide, that is carbon dioxide, acidic in nature, that reaction producing two products. They are here salt and water. Here the salt is calcium carbonate and it can form water, right? So this is the reaction you are observing. So these are also given as example for neutralization reaction, right? So here, depending on the strength of acid or maybe the strength of base, that salt nature maybe changes into acidic or basic. It depends on what strength of the reactants. If acid stronger than base, salt nature will be, can anybody guess? If acid strength is more, stronger acid, weak base, what you will get? The nature adopted by the salt is acidic. Very good. If the base is stronger than acid, then the salt nature will be adopted by basic. So here this is reaction we observed in the activity 6. Is there any confusion in understanding this? Conducting this, that means procedure of conducting the activity, same as your activity number 5 only, but here you are adding directly solid or a gas invisible. So you are not following complete steps, just observing colors, right? So this is reactions. Is there any confusion in this? Is there any confusion? Go to quick reaction. Are you in confusion? No. No. Okay. So let us take more examples. Textually, only one example is given. I am adding more examples in this. What they are here, that acid is saying HCl reaction with a metal oxide, that is magnesium oxide, right? You can complete that. What you can expect the products here? Can anybody complete that reaction? Tell me the products. Tell me the products.
Magnesium.
Come again.
Magnesium chloride
And
water.
Magnesium chloride and water. Now I am taking calcium hydroxide and carbon dioxide. Already we are taken, right? So one more example here. HCl reaction with lead oxide. Can you write the products? HCl and lead oxide. Products, please. Products. By the reaction of HCl and lead oxide. If you know the valencies, it is easy to write as per your 9th class crisscross method using radicals. So here, if you add any compound into the water, what happens? They can split into ions, right? Pb 2 plus, O 2 minus, as per valencies, radicals written. Next, HCl into H plus and Cl minus. So opposite combinations, right? Opposite combinations. So Pb 2 plus and Cl minus. So radicals oppositely exchanging. So what you will get here? Pb 1 and Cl 2. So the products are expecting here PbCl2 and H2O, right? PbCl2 and H2O. Then one more example here, sodium hydroxide, basic in nature, and non-metal oxide, that is carbon dioxide. What are the products here? What are the products here? They are here sodium carbonate and water, right? So these are the examples. Let us go for another activity here, activity number 7. So already I told you what happens if you add base or an acid into the water. What I have written here previously, H plus O2 minus, right? One more example, what we are taken, PbO, right? on adding Pb2 plus O2 minus. So these are the ions produced. So dilution of acid or base. Dilution means mixing in water, added by water, right? So dilution of acid or base, what they are giving you? Producing ions, anything. So we need to realize that. Is they really producing ions or not? So here we are depending on the electrical conductivity, right? We are depending on the electrical conductivity of liquids. So this chapter is there in your 8th class, electrical conductivity of liquids. So when the liquids conduct electricity, anybody just answer me. When the liquids conduct electricity, always suppose I'll give you a liquid that is namely distilled water. Is it electric conductor?
No, sir.
Why it is not an electric conductor?
There is no dissolved particle.
That means what dissolved particle means? Suppose if I add salt in this NaCl, what happens? Distilled water added by salt, what happens? Nothing happens.
Electricity passes.
Electricity passes, right? So here electricity passing through that NaCl solution, but not distilled water, right? Because here in NaCl produce ions in the water. They are namely here Na plus and Cl minus. These ions, not only these ions, no ions in distilled water. So that is the reason. So without ions, no conduction of electricity. Have you got idea why I am explaining this concept? Right? So without ions, no conduction of electricity. That we learned in 8th class. Electrical conductivity of liquids. So here without ions, no electricity passes through any liquid. So now we are observing that electrical conductivity of liquids using here different solutions, right? Acidic solutions, basic solutions, neutral solutions, etc. Right? So here simply acid and bases conduct electricity. What is the purpose of conducting this activity? The purpose of conducting this activity, acids, bases conduct the electricity or not, to verify that. So here my aim is to observe the electrical conductivity of acids and bases. I don't know whether they conduct electricity or not. To confirm that, I am conducting this activity, right? So here I am going to observe that in this activity. So what are the materials required here? So I am realizing only acids conducting the electricity, or only the bases conducting the electricity, or the neutrals conducting the electricity. That I will realize, right? So simply I can collect different samples here. Acidic nature samples, basic nature samples, neutral samples, right? So here, if you observe the table 1 in your textbook, first 4 compounds, once see them, what you can realize by observing the first 4 compounds in the table 1. Go to table 1, study it, then give me your observation from the table 1. What do you say? First 4 compounds. What the compound having commonly in them? What they contain? What is present commonly in them? Did you see any common available? First four compounds. What they are? HCl, H2SO4, HNO3, and CH3COOH. What the nature of these substances?
Acidic in nature.
Acidic. All these are acids. What they are having commonly in them?
Hydrogen.
It can go.
Very good. Having hydrogen commonly in them. Oh, not common, because here see, HCl does not contain. Right? So no oxygen in all, but hydrogen present in all that. Right? So maximum compounds which are acidic in nature contains hydrogen. All the hydrogen containing compounds are acidic in nature. Do they produce ions? We can realize. Right? So that also we can realize here. Right? So based on that, I am collecting the different samples with hydrogen. So they are here glucose. What is the formula of glucose? C6H12O6. Then alcohol. It may be ethyl alcohol or methyl alcohol or any other else. So ethyl alcohol C2H5OH, methyl alcohol CH3OH, right? So like that. Then hydrochloric acid, HCl. Next sulfuric acid, H2SO4. Next sodium hydroxide, basic in nature, right? Then here I need current supply, power supply, to verify that the current is passing through them or not. 230 volts AC plug. That means just you need to plug in socket, right? So that you require. Next, electrodes and connecting wires to make a circuit using liquids, right? So these are minimum required things. Then one more required to verify that current is passing through the liquid or not, that with the help of bulb, right? Next, I am taking distilled water to identify. So in the distilled water, I can add any solution. Every time I will prepare a solution, adding a HCl into the distilled water, adding glucose powder into the distilled water, adding alcohol into the distilled water, adding sulfuric acid into the distilled water, adding sodium hydroxide into the distilled water. Always I will follow the same process. Adding any sample into the distilled water. Are you clear? Or any confusion? I am making the solution using the distilled water only, because distilled water has no nature, right? Neither acid nor base. It is what? Neutral. So that is the reason to take distilled water here. Then procedure. What to do here? In the procedure, you need to take a beaker, right? In your activity, it is suggested to take a plastic mug. You can take a plastic mug, right? Then arrange the electrodes. Electrodes not available with you, so you can use iron nail size electrodes, right? You can use iron nail size electrodes here. So simply I have taken a beaker. I am placing electrodes in it. Directly they won't contact. Make them to stand using something glue or something, a rubber cork, anything you can use to make them stand parallel to each other. They do not contact each other directly. They must be come in contact one with the other with the help of a liquid, right? So these are electrodes. Now I am connecting that electrodes with the different colored wires, right? To connect it with positive terminal of the source and to connect it with the negative terminal of the source, I am following different colors, right? So two electrodes are connected with the positive terminal and negative terminal of the source. So eyes you see here. So that are connected, left wire minus, right, into the AC plug, and this terminal is connected to the bulb to the electric source. So this is AC plug. So into the socket, that wire is inserted. Next, from this red colored wire, I am connecting the bulb. I am connecting the bulb here. So bulb is connected. Then next, connect from the second terminal of the bulb to the another terminal of the AC plug. So this you required. Have you cleared how to make or how to arrange the apparatus here? Did you see that clearly? Yes. So now what to do? We need to verify. Adding the different solutions which you prepared by using the dilute water, distilled water and the samples. So add every time different solution by clearing the glass beaker completely dry. Right? Completely it must be dried. Okay. Or make these type of arrangements with 4 beakers and electrodes, everything separately. Individually you can prepare these arrangements. Right? How many you want? That many. Or make them dry compulsory before adding another. So I'm going to add now. Add distilled water. So indicating the electrodes here, adding a distilled water into this beaker. So filled up to some level. Then stop adding. Then what to do? Here you need to switch on. You need to switch on. What happens if you switch on? All right. What you need to observe here, this liquid conducting the electricity or not. If it conduct electricity, what do you realize? Bulb glows. Bulb glows. So in this case, is there any glow of bulb? It is not glowing. So no glowing of bulb in this case. No glowing of bulb. So what does it mean? The distilled water conducting the electricity? What do you answer me? Distilled water conducting the electricity? Does it conduct electricity? Say yes or no. No.
No, sir.
So in this case, distilled water does not produce any ions. That is the reason the bulb not glow. This was the reason. So what to do? We have to change the liquid. Distilled water, we confirmed, not conducting the electricity. So now you need to remove the distilled water. After removing that distilled water, in a fresh dried beaker, dried electrodes, everything dried, then add another solution which you prepared. So I am filling this with a solution. That solution here is HCl solution, diluted, because I added few drops of HCl into the distilled water. So dilution, concentration of HCl decreased. So that is called a dilute HCl. So dilution of HCl. Then switch on. What happens? See here. What happened when you switch on? The bulb glow on. Right? So what do you say here? What you can answer? What you can answer? Bulb blown. What you realized? No answer. Here, simply bulb glowing because of what? Reaching electrical energy to the bulb. Source supplying energy to the bulb. So that is the reason to say here, dilute HCl is conducting the electricity. Dilute HCl conducting the electricity. Now I can change it. Right? Switch off and change the solution. Then now I am taking the solution is glucose. Again switch on. What happens? The bulb glows or not? The bulb glows or not? That you need to realize. So in this case, bulb not glowing. So in which case we observed bulb glowing? In case of HCl, bulb glown. Yes. In case of glucose, not. In case of distilled water, not. Right? You can conduct this activity by taking the different solutions. Right? Suppose here I can take another solution. Again, switch on that. Again, switch on that. Did you see any glowing of bulb or not? Realize no glowing of bulb in case of alcohol also. Then change the solution. Take a dried fresh beaker, dried electrodes. Then again, fill it with another solution. That is here, sodium hydroxide solution. What happens if you switch on? Observe. So bulb is glown. Bulb is glown. So what I can write here? Bulb is glown in case of this sodium hydroxide. In case of sulfuric acid also, you can see that bulb glow. So which are glowing the bulb here? Acid, base, right? So which are taken here? Acid and base. So that acids and bases are producing the ions in the water. Ions produced by them. So that's why you are observing the glowing of bulb here. Glowing of bulb here. So simply, what about alcohol and glucose? Alcohol and glucose, chemically they are C6H12 O6 composition formula, and alcohol is suppose methyl alcohol taking CH3OH, methyl alcohol it is called as. Then these are producing ions? No, containing hydrogen but not producing ions. So these are not acidic in nature, containing hydrogen but not acidic in nature. So this is completely about activity 7. What are your observations? Only the acids and bases are producing ions and they are only conducting electricity. They are only conducting electricity. So this is observation here, right? So any confusion in this activity, talk to me. Unmute and give me your response. How this activity is clear or creating confusion, or you need any clarity? Is there anything missing clarity in this? No confusion to anyone? Tejaswini and Medashri.
No, sir.
Right. So thank you for joining live class. We'll meet in our next class by tomorrow, 6:45 a.m. in the morning. Thank you.